Welcome in the third section of Apache Cassandra course, and in this section we'll be looking at the topic of diagnostics of our Cassandra database. So we will be trying to understanding Cassandra files and how Cassandra is storing data on disk. Then we'll be using Node tool to examine various performance metrics. Next we'll be looking at the logs and logs that Cassandra is producing. And at the end we'll be choosing proper compaction strategy. In the first video we'll be understanding files in the data directory. So we will be looking at the topic of how Cassandra is storing data on disk. We'll be looking at the SSTables. We'll be examining Cassandra write path, and we will answer a question of how data is written in the Cassandra. So let's look at the stages of writing data to disk in Apache Cassandra. So Cassandra processes data at several stages on the write path, starting with the immediate logging of a write and ending it with a write of data to disk. Cassandra is logging data in the commit log. It is writing data to the mem table that is in memory structure. At some point in time, Cassandra is flashing data from mem table to disk, and it stores data on disk in SSTables, and every SSTable is immutable, so we cannot modify it. So when a write in Cassandra occurs, the Cassandra database stores the data in a memory structure called memtable, and it uses that to provide configurable durability. It also appends writes to the commit log on disk. The commit log receives every write made to Cassandra node, and these durable writes survive permanently even if power fails on a node. The memtable, on the other hand, is a write-back cache of data partitions that Cassandra looks up by the key. The memtable stores writes in sorted order until reaching a configurable limit, and when that limit is reached, the data is flashed to disk. So let's look at the write path diagram. So we have a write operation, and the write operation goes to commit log, and this is persisted on disk. So this will be stored and durable even if the node will restart. Then data is written to memtable, and this is in-memory data structure, so this is a very fast write operation. Then, when on the other hand, client wants to read data from our Cassandra node, it can read data from memtable if that data is still there, or from SSTable if in the meantime on the write path data was flashed from memtable to SSTable, so it was flashed to disk. So read could read data from memtable or SSTable. And every SSTable is immutable, and compaction process is merging those SSTables. So for example, if we have a row for the key A in SSTable 1, and then we want to delete that, Cassandra will mark it as a tombstone record in another SSTable, and compaction process will create yet another new SSTable without that record. So we deleted the record, but everything is still immutable. And let's look how flashing data from memtable to disk looks like. To flash the data, Cassandra writes the data to disk in the memtable sorted order. When the memtable content exceeds the configurable threshold, or the commit log space exceeds the commit log total space in megabytes configuration parameter, the memtable is put in a queue that is flashed to disk. The queue can be configured with the memtable heap space in megabytes or memtable of heap space in megabytes settings in the cassandra.yaml file. If the data to be flashed exceeds the memtable cleanup threshold, Cassandra blocks writes until the next flash succeeds. This is very important to remember that memtables and SSTables are maintained per table. So the commit log is a shard among tables, on the other hand. So SSTable and memtables are per table, and commit log is shared among all tables. And SSTables are immutable. There is no possibility to write to SSTable again after the memtable is flushed. And consequently, a partition is typically stored across multiple SSTable files. A number of other SSTable structures exist to assist the read operation. And let's look how write path looks like, but more in depth. So we have a write data request. It is written to commit log. Commit log is per all tables, and to memtable, that is per table. Then after that threshold of megabytes is reached, that memtable is flushed to SSTable to disk. And this is also per table.